Number 8. The resistance of one of the circuit in the armature of an AC generator is measured at room temperature of 22 degrees Celsius and found to be 0.0642 ohms. After the generator has been in operation for 6 hours, the resistance of the same circuit is again measured and found to be 0.728 ohm. Determine rise in temperature at the end of 6 hours. Okay, so let's evaluate the problem. So we have an AC generator, and at a room temperature, it was measured. The room temperature is 22 degrees Celsius, and the initial resistance is 0.0642 ohms. So this would be our R1. And after 6 hours of operation, the armature circuit is being measured again, and with the value of our resistance of 0.728 ohms. That would be our R2. Okay. Based on the statement of the problem, the temperature coefficient is not defined, but they give us the room temperature. So that would be our starting point in determining our temperature coefficient. Okay. So before that, let's recall the formula for your resistance with respect to temperature. That is the final resistance over the initial resistance, 1 plus the temperature coefficient times change of temperature. Okay, so in the problem, temperature coefficient is not defined. So let's start with that. So since our AC generator, the commonly material used in our AC generator circuit is made of copper, so let's assume it's copper. So for our temperature coefficient at room temperature 22 degrees is equal to 1 all over the T, the inferred temperature of a copper, that is 234.5 plus your room temperature 22. So your temperature coefficient is equal to 0.003898,635. Okay, so this is our temperature coefficient. Okay, going back to our formula, we have our final resistance, initial resistance, and we can rewrite our formula with respect to our new temperature coefficient. So that is R2 all over R1 is equal to 1 plus the temperature coefficient 22 at your final temperature. So we're going to use this formula in order to determine our final temperature. Okay, doing that, what is the value for our final resistance? That is 0.0728 ohms all over the 0.642 ohms equal to 1 plus, we're going to save the temperature coefficient to our alpha A, okay? So I'm going to use alpha A here. Alpha A times your final temperature. So finally, our final temperature is equal to 34.35 degrees Celsius. So this is our final temperature. But wait, the problem is determine the rise in temperature. He is asking for the change of your temperature. That is your delta T. Okay? So let's determine the change of the rise of the temperature. So your delta T is equal to your final temperature minus your initial temperature. So your final temperature is 34.35 and your initial temperature is at room temperature, which is 22. So finally, your delta T is equal to 12.35981308 degrees Celsius. So the rise of temperature is 12.35. Okay?